for hybrid warfare.
Thank you again. Honor to be here. This is not possible without the strong support of the entire ecosystem, including Ministry of IT, DST. I've listed several of them will come up in the discussion. Now, sovereign LLM for hybrid warfare. What is sovereignty? There is a political aspect of sovereignty. Quoting from Acharya Chanakya, the happiness of subjects lies the king's happiness. But there's a functional aspect of sovereignty, which is the translation of what and why to the how, right? Which requires material systems. Now, the GPUs for building large language models are basically the bulk of the expense in building these models. Unless we have the functional sovereignty in terms of technology, supply, economy, infrastructural independence, and obviously the knowledge systems, the co-design with the stakeholders, which also means there's a people and the territory, the law, policy, sensitivity of the models, you will not be able to do what was being alluded to as proportional navigation in the space by Professor Ghosh. Right? So sovereign LLMs enable innovation. Right? While we want to go leapfrogging from the word go, the challenge is unless you do some of the benchmarking and recipe building, you will not be in a position to leapfrog. So this is the ecosystem that is actually required to bring sovereign LLMs for hybrid warfare. The first is recipes and indigenous models. But along with that, you need to ensure that these are powering technology development through research, which is the second pillar. The third pillar is incorporation of knowledge, and this is not possible with close collaboration with the stakeholders. So at IIT Bombay, we have a Center for Defense Technology Innovations and Strategy, CDTIS. We also have a Maharashtra drone mission. All the work we do in LLMs is in collaboration with them, and obviously this is an open call for participation. And this is a virtuous cycle. We're able to go back and bring in data into the model building exercise. How do you make this happen? Let's start with the first part. The first pillar, which is building glass boxes rather than black boxes, which are these large language models. Now, going back to 2017, Ashish Vaswani and his team, an Indian, right, they brought out this very interesting innovation called the transformer. Attention is all you need. What is this? I have a simple example here. Sonar systems are vital for maritime defense. Everyone here in the audience is in a position to try and complete this sentence. Hence, Atmanirbharta in sonar systems is important, right? That's possibly how you complete. How does a model get trained? Well, it is through something called query key value based attention. So you have a query which is hence, which is attending the Q matrix there. This is the only equation in the entire slides. This is going to attend to all the potential keys in the preceding words, all represented through vectors, and this gives you weights associated with the values on what are potentially going to help predict the next set of words. This can be extended to vision, to geospatial data, the same principle, right? And you're training the model in a self-supervision manner. Now this is also interesting because a recent paper, October 2025, has shown that there is a lot of injective mapping preserved, which means if you look at the intermediate layers of this large memory bank called the transformer, you're able to kind of recover the source. Not only is the memory part here, you would also heard of mixture of experts from DeepSeek, the feed-forward neural network, which is at the top. When it's composed as a mixture of experts, it also brings in the ability to have resource-friendly computation through reasoning, which means through attribution of what computation is attributed to which expert. So mixture of experts comes the feed-forward neural network. But then that's not all. The co-design principle is what I've seen. Flash attention. A lot of innovation on how you kind of structure the entire quadratic complexity across a very memory-friendly HBM and a compute-friendly SRAM. And how do you ensure that these two are reflected in algorithm design? So flash attention 1 did something called tiling, sliced these query key value pairs. Flash attention 2 went ahead and said, well, what if we do a loop inversion? And not only that, it also did a lot of improvisation in the way these computations are done. Flash attention 3 brought in block quantization. Now and a lot of scheduling with respect to the warp, the way the entire CPU, the tensor, which is all responsible for the non-matrix multiplication and the matrix multiplication operations, and the CUDA, which is responsible for the non-matrix multiplication operations. Now, this trilogy is inspirational, but what do you do locally? So, thankfully, the India AI Mission and the Department of Science and Technology trusted in our efforts and helped set up this BharatGen, India's sovereign Gen AI ecosystem. It's a call for participation. The mission and urgency is because if we have to target 2047, we really need to make sure that we are doing cutting-edge research and leapfrogging in this space while being sovereign and culturally sensitive. It's anchored as a Section 8 company at IIT Bombay with 10 academic consortium members. We have 60 experts. We've got top talent back from the US into India. There's a good example of what is possible, but there's a lot of work to be done, long way to go, with a total funding of 123.6 crore. Because it's anchored in a Section 8 company, delivery is very important. And all the models are available on Hugging Face and AI Coach. Now, the second pillar, how does research enable leapfrogging? If you look at attention, which is quadratic, and state space models, which came later, which have not yet seen the light of the day in these large models, the state space models make this into a fixed size vector instead of quadratic attention, and they get an order n complexity, which is very welcome, but explainability is lost. So how do you marry the two? In computer science, there's a concept of no free lunch. You don't get anything for free. So it's a trade-off, right? Understanding this trade-off is actually as important. For example, when you're training a large language model, the initial phases of the training, self-supervision, would require you to reinforce concepts in the model. Whereas in the later stages of the model, the figure on the right, top left, you would like the model to be exposed to more diversity. But what is that right inflection point? Mind you, today's large language model training is extremely inefficient. How do you bring efficiency and reasoning, as was alluded to by Professor Ghosh? On the other hand, if you look at the right side, data efficiency, you have massive training corpora. Is there a subset of the data that is effective enough to train these models? How many bulbs should you have lit in this room so that the illumination is effective in this room, right? So it's a problem of subset selection. You also have adaptive intelligence, where a model which is in its nascent stages could actually give insight into how the model would be when it evolves with the data. In the interest of time, I'm going to skip to the third pillar. This is very important. How do you, hybrid warfare is not possible without co-design. So I talked about the two missions we work closely with, the understanding human intent, to have hybrid warfare, while we can have perception, knowledge, collaboration, and this is what we did maybe almost a decade back. We built a whole bunch of technology for adding intelligence to cameras. Now there are plenty of companies in this space, but thankfully our work was recognized. We worked closely with the Naval Dockyard at Visakhapatnam, Karwar, and Kochi, and this entire work also won us a lot of appreciation. We won National E-Governance Gold Award. The important thing is it got deployed, it got widespread appreciation right in our campus. Obviously, charity begins at home. It was used during COVID for surveillance. But this is just the first layer, right? The actual part is cognition. That's where things are today. Cognition, action, making it actionable because you anticipate the next movement. That's very important, right? And that's when you can also do reflection and evaluation, right? So coordinated use of cyber, information, electromagnetic, economic, and autonomous system attacks. Just building upon Professor Ghosh's example, if you have basically a whole army of drones, how do you do short-term density mapping? How do you have 3D reconstruction, vision, based on computer vision, and bring in long-term mapping, map it to SLAMs, ensure that in that process, the communication through ultra-wideband short-range UWB, is actually being co-designed. The algorithm for communication is co-designed with the model interpolation. And then finally, coordinated swarm navigation. Here's an example of a dynamic target being chased by a swarm. The swarm, the ones in red at the front and the ones in blue are at the front of chasing the white target. The ones in the red are following the blue. The swarm navigation also needs you to do very effective edge computation, which again Professor Ghosh pointed to. Now there are some very good startups. We work closely with MiFi. they have done an excellent work. MiFi, Micromax and Phison joint venture, they try to come up with this MiFi card, AI adaptive card, which lets you do sharding of these large models, right? So that you can actually augment your L2 cache and have through a firmware, a middleware, the model collaborate across these sharded models and have inference and also training done effectively of very large models. So this obviously takes us also to other areas. How about AI-driven cyber defense? I know we have run out of time, so I'll leave some of you to look at the slides in retrospect. But the important part here is the ability to get the big picture is what large language models bring in. And integrating that with domain knowledge is very important. A simple example, retrieval augmented generation, many people have heard of. How do you ensure that the retrieval part, honestly, RAG has failed in many cases because the retrieval part is just taken to be a cosine similarity, a very nice similarity. Domain knowledge becomes extremely essential to ensure that RAG is successful, right? So, I mean, if you had to use RAG effectively, for example, in cyber defense, and here, I mean, what does it mean to use a large language model in cyber defense? Here's a simple example. I have multiple databases, a toy example from OS query, and using the logs, being able to translate a query like find all failed login attempts and group them by source IP and username. Very toyish example, right? You're able to do that by interpolating across multiple databases. Can you do that? Can we extrapolate on that? Harden, detect, isolate, deceive, evict, and restore. This is what is the offering in terms of the entire sovereign ecosystem. Please do read up a very interesting blog called Situational Awareness, which will actually argue for the participation at the national level in the building of this AI infra. I'm going to leave you with this thought. Can we have a defense industry academia ecosystem where obviously the ultimate stakeholder is the defense forces, but can we have educational institutes and in the industry work together, co-design, in that process make sure that the co-design also involves the end stakeholders, in this case the defense forces. Thank you very much. I'm very grateful to this opportunity.
Thank you so much, Professor. Really passionate, and we could have listened to you for hours. I had two questions which you could take on later. One is that have you had interaction with the INICAI, that Indian Navy's AI, your mission? And the second is, how did this, the DeepSeek almost sort of sent NVIDIA spiraling down, saying that GPUs are not really that important? We could clarify that a little later. So now may I request our last speaker, Professor Anand.